Solutions for the mock exam for exponentials. Number 1, which you can use the calculator for. A group of 10 leopards is introduced into a game park. After 2 years, the number of leopards n is modeled by n equals 10 times e to the 0.4t. How many leopards are there after 2 years? Give your answer to an appropriate degree of accuracy. You can, of course, just type that into the calculator without using the y equals function, but let's use the y equals function so you can see how easy that is. It allows you to answer a lot of the other questions too. So we're going to first put in the equation 10 times e to the 0.4t. E is found here, the second natural log function, e, and then you put 0.4, and there's no t, so you put the x. And then we are going to see how many leopards are after 2 years. That is when x equals 2. And if you do second table, it's going to show you the value that n will take on for every value of t. You can see that my table's all screwed up. It's got really small jumps to it. So let me fix the table. I'll go back to second table set, which is here. And then I will change the table start to 0, and I'll change the delta table to 1. Now I'm going to do it again, second table. Okay, so now it says how many leopards are there after 2 years. It says 22.255. It says give your answer to an appropriate degree of accuracy. Now it makes no sense to say 22.255 leopards. We should say either 22 or 23 leopards. So let's say 22, because maybe 22.255 is closer to 22 than 23. You could make a case for putting 23 also, so I'm sure the IB would accept either answer, 22 or 23. Let me put here 23. How long will it take for the number of leopards to reach 100? Give your answer to an appropriate degree of accuracy. For this item, 3 significant figures. So if you go down here, you can see that it would be between 5 and 6 years to get to 100 leopards. Now, how many exactly? Now, I'm going to show you a couple ways to do this. It's good to watch all the methods because in some problems it might be easier to do one than the other. Okay? So the first thing I'm going to do is I'm just going to increase the increment. They want 3 significant figures, so I'm going to increase the increment to plus 0.01, and that's going to give me 3 significant figures. By doing this, now I can find the exact value for up to 3 significant figures of time that gives us exactly 100 leopards. Getting close. Oh, there we go. Oops. So, looks like it's going to be between this one and this one. 100.14 is closer to 100 than 99.7. So let's say it's this one. So it's 5.76. 5.76 years. Okay? And let me show you one other way to do this. We could go up to the y equals function input, and we can put in a second function, which would be 100, y equals 100. So basically this is going to be a horizontal line at y equals 100. This is going to be an exponential function which is descending or I'm increasing and will eventually cross 100. The moment that this first function crosses the function y equals 100 is the moment that the population of 100 leopards is reached. Let's graph it. By graphing it, we can see both. I'm having trouble here. Oh, there we go. Okay. Okay, so there's our exponential function, and the y equals 100 function is way off the screen because this screen only goes up to a smaller value than that. So let's change y max, for example. We'll change it to 110 to make sure that we'll get that horizontal line. There we go. So we're looking for this intersection right here. The way we can find that intersection was second calc intersect. Okay, there is, okay. So it says first curve. I only have 2 curves in the database, so I can just answer yes to both of these. Yes, if the first curve is e to the 0.4x. Second curve, yes, the second curve is y equals 100. There's only 2 in there. Is your guess 0, 100? Yeah, that's fine. It doesn't matter what guess you have because it only crosses in one place, so your guess can be anything. Your intersection is 5.76, 100. What do you know? 5.76. Okay, so those are 2 different ways to find the answer to 3 significant figures. Now we're going to move on to problem 2. Calculator is not allowed on this one. Let's see. It says to solve this equation. Solve this equation basically means what value of x makes this true. We have an exponential expression on both sides, right? And you can see that there is a pattern here. It looks like it's multiples of 3 is the pattern. So can we write each of these expressions as an exponent of 3? And if we can, then that means that we can equate the exponents. Okay, so for example, 9x to the minus 1. If we were to write that as an exponent of 3, we could write 3 squared, which is 9, to the x minus 1. What about 1/3? How do we write 1/3 as a exponent of 3? We could put 3 to the negative 1, right, to the 2x. Okay. Now remember that we can combine exponents here by multiplying them together. So 3 to the 2x minus 2 equals 3 to the negative 2x. Now we're going to equate the exponents. We're going to equate that with that. They have to be equal in order to solve this. Okay, and then we're going to add 2x to both sides. We get 4x minus 2 equals 0. And then we're going to add 2 to both sides. We're going to get 4x equals 2. So x is equal 1/2. Now we could go back and check that answer by putting it in here. So we'll have 9 to the 1/2 minus x, which would be negative 1/2. And then on the right side, we'll have 1/3 to the 2x, 2x being 1/2, so it would be 1/3 to the 1, which is just 1/3. Is that true? So let's see. Is 1 over 9 to the 1/2 equal to 1/3? Yeah, because 9 to the 1/2 is 3, so 1/3 equals 1/3. Yeah, so we have checked our answer, and it appears to be okay. Last problem. Consider the function f of x equals 1.25 minus a to the negative x, where a is a positive constant and x is greater than or equal to 0. The diagram shows a sketch of the graph of f. The graph intersects the y-axis at point A, and the line L is its horizontal asymptote. Okay, so this is the horizontal asymptote. It sure looks like it. The equation of the graph is that. We don't have complete information. We don't know what A is. We just know it's a positive number. So the first thing it asks us is, find the y-coordinate of point capital A. So we have the function, but it's not a complete function. We don't know what A is. Now what is the x-coordinate of A? X-coordinate of A is obviously 0, right? Now if we put in 0 in for x here, we're going to get 1.25 minus a to the negative 0, which is just 0, right? What is any number to the 0 power? It's equal to 1. So 1.25, even though we don't know what a is, we know that whatever number it is, to the 0 power, it's 1. So f of 0 is equal to 0.25. Okay, so the y-coordinate of A is 0.25. Next question. The point 2, 1 lies on the graph y equals f of x. Let's see, 2, 1, let's say it's about here. 2, 1. Calculate the value of A now. Okay, since they gave us one pair of points which correspond to each other, x equals 2, y equals 1, we can plug that in to the function y equals 1.25 minus a to the negative x. So now we know that the y is equal to 1, and we know that a to the negative x is a to the negative 2. So let's see, that would be, we could subtract negative 1.25 from both sides. That will give us negative 0.25 is equal to negative a to the negative 2. So we could make both sides positive, and we'll get 0.25 equals a to the negative 2. A to the, let's see, we could invert both sides, so we'll have 1 over 0.25 is equal to a to the a squared. Okay, we inverted both sides. We took the negative 1 power of both sides, and we ended up with a squared equals 1 over 0.25. 1 over 0.25, guess what that is? It's 4. So it's a squared equals 4, so a is equal to the square root of 4, which is 2. Okay, and we know that a is a positive constant, so we know that it's 2 and not negative 2. So the value of a is 2. Now it says write down the equation of the asymptote, the line L here. Basically, if you take the equation 1.25 minus 2 to the negative x, and you want to find the asymptote, you could just put a really big number in for x. If you put a really big number for x, you're going to get 2 to the negative, like 100, right? 2 to the negative 100 would be 1 over 2 to the 100. 2 to the 100th is a huge number. 1 over a huge number is basically 0. So this is basically 0. And you can see that the asymptote is your constant, which is right there. And you also discovered that during your investigation about exponential functions. So basically, the equation of L is going to be y equals 1.25. Okay, and that is the last problem for this test, or for this mock exam.